Yeah, hello everybody, my name is Thomas Gruenewald. I'm also from Siemens Corporation in Princeton. I'd like to thank you everybody for this great project participation. In the last 2 years it was a lot of fun working with everybody together, and I think we achieved a lot. I have only a short presentation, so I think I'm actually happy to catch up some time. It's about a tool which we developed. It's called Demand Response Capacity Assessment Operation Assistance Tool. Very long name, and it describes everything what it does, so I could end here. But I have some pictures and some slides which I'd like to show to you. My agenda very short: objective, architecture, and some demo pictures, I have to say. So what is that tool about? So basically, when you have a building operator and you know about all these utilities offering incentive that you're participating if you participate in demand response. So you really don't know what your building is capable of. You have maybe a building management system like we have here. You have strategies, you can run your building. And so you want to evaluate what is your building really capable of. How much load can you shed before you sign a contract with a utility, and in the end you pay money because you cannot make the numbers. Now, so we did that little tool which gives you a little playground to play around with different strategies. It uses Energy Plus for energy simulation to figure out how the strategies play out in the end. We use historic weather data, for example, for Berkeley, for the last 10 years, to see how the weather pattern play a role here. And so obviously you can use it for demand response, but what we heard also, energy efficiency is also very important. So you can use it for both cases. And in the end, it shows you which strategy would play best, and then you can determine what demand response program you want to sign with your utility. A little bit from the architecture and workflow. The application is pretty simple. So we import basically an IDF file. IDF is a building model which we use in Energy Plus. We can import weather data, two types. Either we import statistical weather data or current weather data. Statistical weather data you use to do weather classifications to figure out, do we have certain weather patterns, and then run it with your building energy strategies. Or you use it current weather data to figure out what strategy would be work best tomorrow. And then you run it basically in your Energy Plus, and it selects the best strategy and gives you some output. Now, that's the way the application looks like. It's a dialogue-based application, and I play through the demo by showing you different pictures. So basically, we select an ITF file, a couple of weather data files, which are for different years to see how now basically for here, California, this area from 1999 to 2007. And when we have done that, we determine what period we want to assess. So in that example, from August 1st to August 31st. We can put in some pricing information like off-peak and on-peak. And what we do, we run then a weather classification. And you see all these different lines show with the imported weather data some weather pattern. So this weather pattern we use then later on to figure out what would be the best strategy based on these different weather patterns. All right. What we also have, we talk about buildings management strategies. And what you have, you can think about a building management system has different things it can do, and that's the so-called strategies. So you can say, I want to have a constant cooling, I want to keep the building on 70 Fahrenheit all day long, or you keep it more flexible and so on. So that's a kind of feature set your building can basically handle, and the equipment runs in a certain range of technical specifications. So I can take some of the strategies for evaluation, which I believe would be the best, or I select all of them. In that example, I selected few of them. All right, after I run this calculation, running with Energy Plus and consider the weather pattern, you see mainly two curves. The red one basically shows you the business as usual, that what would happen if you wouldn't do anything. And the green one actually is used, we see a kind of pre-cooling, so more energy is used in the beginning. But when we hit the demand response event, we keep almost the curve pretty flat, and when the demand response is over here, we can cool again and keep it to a comfortable level here. Now, what you're also interested is basically, if you talk about energy efficiency, really how much power you save. You can also put some data out how much peak you can reduce. And if you talk about savings, you want to know also the dollar amounts. That's what really counts for you as a building operator. Yeah, so overall, that's my presentation. If you have questions, please feel free to ask now.
Okay, thank you very much, Thomas.